Hey, I'm Marty Johnson, and welcome to Marty on Materials. Today I'd like to talk to you a little bit about how we classify materials. What makes a material tough? What makes a material durable? How do we define that and put that onto our website so that you can find the right material for your application? So one of the things I want to show you today is we put together a chart based off of the Flexural Modulus. And this is a really good way to go in and define the different materials and classify them so that they can be chosen for the right material property per the application. If you look at this chart, I'll start from the left. You've got rigid materials. Those are materials that are greater than 2200 megapascal flex modulus. These materials tend to have higher HDTs. They tend to have lower elongation at breaks. So a lot of time you'll see these used as cover parts or things like that. When you get over into the tough section, the tough is going to be similar to your ABSs. It's going to run between about 800 or 1100 and 2200 megapascals. You're going to have a good balance of HDT, a good balance of your flex modulus, your tensile, your notch impact. As you see those kind of come together, they'll define those tough materials, and they tend to have a good repeat load. If you think of repeated loading, that's where a lot of your tough materials are going to come in. And then when you get to the durable materials are some that have a little bit more flexible. They're going to be high impact, high elongation. They will give up some HDT and tend to have lower HDTs, but they can really take the shots from the impact. You can really have these things where they can really twist and turn. You'll see this is one of the Flex Black 20. You can really get a lot of extra out of the durable materials if that works for your application. And then of course the rubber. The rubber parts tend to be lower than the 500 megapascal flex modulus, and your rubbers are going to be some of your Santoprene and Buna-N type materials with, if you look at the Shore D values of where those are, the lower your Shore D, the more flexible, the more elongation you're going to get. So your rubbers are going to kind of land on that end of the Flexural Modulus spectrum. So as you look on our website, you'll see these set up, and you'll see the tough, you'll see the durable, you'll see the rigids or the rubbers, you'll see nylon set apart sometimes, and we even have composites. When you look at the composites on the website, where does that land on this chart? Your composites tend to land in your rigids. You'll see down here in the high performance materials. This is a composite Duraform HST, and this HST material has a really high HDT, up around 166C, but it also has a really high flex modulus, and it really gives you a really nice, professional, long-lasting part. When you get into some of the rigid parts, you'll see those is Pro Black 10. The Pro Black 10 lands over here in the rigids, similar to your PMMAs. You look at this for cover parts. You can hear that snap. You can hear what you get out of these cover parts, because you want those to click and hold their form and not be something that can be deformed. So a lot of times you'll see cover parts as rigid parts. Your tough parts are going to be things that are handled a lot. So that's why when we talk about some of your ABS part, very common injection mold material, if you look at your tough materials, then you're going to see that same kind of toughness that's needed in the repeated loading, and something like handles and grips and something that you can turn and twist that really put a load on over and over again. So when you go to choose that next material for your next additive job or your application, take a look at the data sheet, look at the Flexural Modulus, and go through this thought process and find the best material for your application. So really glad to talk materials again with you today, and I really look forward to hearing from you to answer some of your specific questions on additive manufacturing materials. So please go to the link below, and I look forward to hearing from you soon.